So the first thing it asks us to do is to graph this function in our calculator. So that's what I did right down here. That's what the graph looks like. And it asks us, what do you notice about the zeros? We talked about this a little bit in lesson 5b.2, which is that if you take your factors, since this is in factored form, and you switch the sign of your number, which is essentially because you're solving. So if I'll just do it with one of them. If I took x minus 2 and I solved it for x, I would have to add 2 to both sides, so it's the opposite sign. So I end up getting x equals positive 2. So that's why you have to switch the sign. And there's positive 2 right here. If I did the same thing with x equals 1, I would end up getting x equals negative 1. So I'm just switching the sign. That's right here. And then if I set x plus 3 equal to 0 and solved it, I would get x equals negative 3, which is this 0 right here. So what you notice about the zeros is that if you take the numbers in the factors and you switch their signs, they end up being the same zeros that you see your graph crossing through the x-axis on the graph. So your zeros are opposite signs of the factors. So the whole reason we're talking about this is because if we know the zeros of a polynomial, we can then take those zeros and we can go backwards and write the equation using the distributive property, which some of you may know as FOIL. So what we're going to be doing in this lesson is taking solutions and writing equations. We are asked to find the polynomial of least degree that has the roots x equals negative 3 and positive 2. So I'm going to show you something that you're not going to have to do for every single problem, but I do want to show you one time where these answers are coming from. The first thing I'm going to do is I'm going to label my zeros on the graph because we are going to have to do a sketch at the very end. So I'm going to label, or I'm going to put a point at negative 3 and a point at positive 2. So when I get to the end and I do my sketch, when you graph it on your calculator, you should see that it crosses through at the right numbers. So the first thing I'm going to do is I'm going to rewrite my two zeros separately. So x equals negative 3, x equals 2. Now what I'm going to do is I'm going to unsolve them. So I want the x with the number on the left side of the equation so that 0 is on the right side. So if I wanted to do that with my first one, I would have to add 3 to both sides. So I'm doing the opposite so that it cancels out and gives me 0, and that would leave me with x plus 3. And then I'm going to do the same thing here, so I'll subtract 2 from both sides so that the 2's cancel, and I would have x minus 2. So now what I'm left with here, that I'm putting a blue box around, those are my two factors. So what I'm going to do is take those, and I'm going to put them in parentheses, and now I have to distribute those so that I can get my polynomial. So the shortcut, if you're looking to save yourself a little bit of time, you don't have to do all of this right here. So the shortcut would be to just flip the signs. So if you know that your x is negative 3, when you put it into parentheses, it should be positive 3. And then positive 2, you would flip and change to negative 2. So the shortcut is to flip the signs. But the work that I just did right here, where I'm putting a red star, that is why you flip the signs. There's a reason, it's not just kind of random. Okay, so now what we're going to do is we're going to distribute. So I'm going to make a box here, and I need to break it up because I have two binomials. That means I need 2 boxes on either side. So now what I'm going to do is take my equation, the things that are in parentheses, and I'm going to label one of them across the top and one of them across the left side. And it doesn't matter which one goes where. I'm going to put the first one on the right side. I'm sorry, on the left side. So I have x plus 3 and then x minus 2. And now what I'm going to do is I'm going to multiply the things that meet to make the box. So for this first top left box, I'm going to be multiplying x times x, which is x squared. For the box in the top right, I'm going to multiply x times negative 2 for negative 2x. The bottom left box is going to be positive 3x. And I'm not writing the plus. You can, but you don't have to. And then for my bottom right box, it's going to be 3 times negative 2 for a grand total of negative 6. Now what I have to do is go through and combine any like terms. My like terms would be things that have the same variable and the same exponent. So that would be these two right here. So those two I could add together. So if I did 3x minus 2x, that would just give me 1x, or you could just write x. So now when I write my final answer, it's going to be three things. It's going to be x squared plus x minus 6. So this right here is my final polynomial. Now what you're going to do is put this into y equals into your calculator, and you're going to graph it, and you want to make sure that your graph crosses through at the same exact points as your as the sketch that we started here. So if your graph doesn't cross through at the same point, you're going to know that you made a mistake somewhere. Now the next thing that you're going to do is you're going to put you're going to look at the table of values, because there's one other thing we want you to add onto your graph, which is the y-intercept. So let me write that over here. So for your graph, we want you to do three things. Number one, we want you to plot the zeros. And those are the ones that you get from your original problem. So in this problem here, my original zeros were -3 and 2, so I plotted those points on my x-axis. The second thing is to plot the y-intercept. The y-intercept is where the graph crosses the y-axis, and the way that you can easily find that on your calculator is go to the table, and then you look for when x equals 0. Whatever your y value is your y-intercept. So I have pictures on here so you can see, but in this problem, the y-intercept comes out to be -6. So what I'm going to do is I'm going to put a point at -6. So I'll write that down here. The y-intercept is 0, -6, so I put a point at -6 on the y-axis. And then the third thing, which isn't really even much of a thing, is just to look at the graph on your calculator and just make sure that your picture matches. So you're just kind of connecting the dots so that it looks like the graph on your calculator. So I'm just going to write sketch the graph using your calculator. So if I looked at the graph on my calculator, it's a parabola. It has to go through my zeros and through the y-intercept. So that would be it. This one's going to be a little more complicated because we now have 3 roots. So the first thing I'm going to do is plot my points on the x-axis. So here's -4, +1, +6. So when I do my graph, which you can actually see down here in the bottom right, it should cross through at those exact numbers. If not, that means we did something wrong. So I'm going to go straight to the factors. I'm not going to spend my time solving, so we'll do kind of the shortcut. So I need 3 parentheses because I have 3 factors. X plus 4, remember we're switching the sign, x minus 1, x minus 6. In order to distribute these, we have to do this in a 2-step process. So the first thing we're going to do is we're going to distribute these two together, and then we'll take that answer and we'll distribute it to my third answer, or to my third factor. So I'm going to do the box again. So because I have 2 terms in each of my factors, I need a 2x2 box. And I'm going to put x plus 4 on the left and x minus 1 on the bottom. And now I have to multiply. X times x is x squared. Now I'm going to move on to the top right box. X times -1 is -x. You could also write -1x. Now I'm going to move to the bottom left box. 4 times x is 4x. And then for my last box, 4 times -1 is -4. Now again, I have to look at like terms. I have 2 x terms here. So if I did 4x minus x, that would give me a grand total of 3x. So I have x squared plus 3x since it's positive, and then minus 4. So x squared plus 3x minus 4. Now what I have to do is take this thing that I just figured out, which was the thing that I put a blue box around, so I'll write it in blue. x squared plus 3x minus 4. And I have to multiply it by my third factor, which I originally kind of ignored. So we're going to do a box again. This time, because I have a trinomial which has 3 terms and a binomial with 2 terms, I have to make a 2 by 3 box. And you can set this up however you want. I like to have the box going the long way. So I need 2 numbers that go on the left side, and then I need to break the top so that it has three terms. So I'm going to put my x minus 6 on the left, and then x squared plus 3x minus 4 would go on the top. So same process, we just have a couple more boxes to fill in. All right, so x times x squared is x cubed. I'm just going to go along the top, and then I'll go down to the bottom. X times 3x is 3x squared. X times negative 4 is negative 4x. Now I'm going to go to the bottom row. So now I'm going to multiply everything by negative 6. So x squared times negative 6 would be negative 6x squared. Negative 6 times 3x is negative 18x. And then negative 6 times negative 4 is positive 24. So now I have to worry about like terms. I see that I have 2x squared terms here. And then I also have 2x terms here. So I have 2 sets of like terms that I have to deal with. So here's what's going to happen. The ones that I put a purple box around, I would be doing 3x squared minus 6x squared for a grand total of negative 3x squared. And then the one that I put a blue circle around, I have negative 4x minus 18x for a grand total of negative 22x. So my final answer here would be the x cubed that didn't have any like terms. Instead of the 2 purple terms, they combined to make negative 3x squared. The blue terms combined for negative 22x, and then the plus 24, which also didn't have any like terms. So this thing right here is our final answer. Now the next thing we need to do is sketch a picture of the graph. So I have a picture of the graph over here that I'm putting a red star next to. It looks kind of funny, and this is what it's going to look like on your calculator when you try to graph it. What's actually happening is that this graph is like it goes up like this, and then it comes back down. So it's kind of making like a squiggle or a big loop. So you can't see the whole thing, but what we're really focused on is that it crosses through at the right x values. If it crosses through at the right x values, chances are it's pretty good. So I want to just double check. This is at negative 4. This is at positive 1, this is at positive 6, so everything looks good. Now the last thing we need is the Y-intercept. So what I did is I put a picture of the table that you'll get when you press second graph to get to the table. So let me write that up here just in case you forget. So if you press second graph, it will take you to the table, and you're looking at when the x value is 0. So this tells you that the Y-intercept is 24. Now I know 24 is not going to fit on this graph how I've scaled it, but that's okay. I'm just going to put a point up here and then I'll label it 24. So now I have to connect the dots. And it doesn't have to be perfect, it just has to have the general shape of the graph. All the zeros need to be labeled and the Y-intercept. This last one looks a little bit intimidating. It actually is going to be slightly easier than the one we just did. There's going to be a little bit of a trick that you'll see. So the first thing I want to point out is that even though it looks like this one has 2 zeros, it actually has 3. And the reason is because of this plus minus right here. What this actually means is that we have negative 2, positive square root 3, and negative square root 3. So when you see a plus or minus, it actually accounts for 2 of your zeros. Now the square root of 3, if you put it into your calculator, it comes out to be about 1.7. It's a big nasty decimal, but we're going to say it's 1.7. So when I plot my zeros on my x-axis, I'm going to have 1 at negative 2, and then I'll have 1.7, negative 1.7, and positive 1.7. So it's okay that it's a decimal. It just isn't as nice to graph. So now here's how this is going to work. I'm going to have my 3 sets of parentheses. 1 at x plus 2, because we're changing the signs, x minus the square root of 3, and x plus the square root of 3. Now this one that's in the second 2 sets of parentheses, something interesting is happening here, which is that they're called conjugates, which is a word you may or may not have heard before, but conjugates means that they're the exact same thing, but one has a plus in the middle, one has a minus in the middle. And we've actually seen these already. This is what the answer to a difference of squares problem looks like. And if you remember, a difference of squares, the original problem, has only two terms. So what's going to happen here, if I tried to FOIL, and I'll show you really quick. So if I did x minus the square root of 3, x plus the square root of 3, x times x is x squared. The square root of 3 times x is square root 3x. This would be negative square root 3x. And then the square root of 3 times negative square root of 3 actually comes out to be just negative 3. And I'll show you off to the side why that happens. If I take negative square root 3 times positive square root 3, the answer is negative. 3 times 3 is 9, so you get the negative square root of 9, but the square root of 9 is 3, so you end up getting negative 3. So that will happen anytime that you multiply two identical radicals. The number will come out and the radical will disappear, and it'll always be negative because you're always going to have one of each. All right, now what's happening here is that these two terms are exactly the same but with opposite signs. So they actually ended up canceling each other out, and all you have left is x squared minus 3. So the shortcut is, whenever you have conjugates, which is what we had here, you're going to only multiply the first and the lasts. First and last terms. So what I mean by that is x times x and negative root 3 times positive root 3. All right, so I have my x squared minus 3, and then I also have x plus 2. So now we have to FOIL one more time. So I'm going to make a new box. This one only has to be a 2 by 2 because I have x squared minus 3 and x plus 2. So now I'm going to multiply. X squared times x is x cubed. X squared times 2 is 2x squared. Negative 3 times x, and then negative 3 times 2 would be negative 6. So now I don't have any like terms. They all use x, but they don't have the same exponents. So my final answer is going to be x cubed plus 2x squared minus 3x minus 6. And it is important that you write it in descending order. That means your exponents start from the biggest and go to the smallest. Now you would take this and you would type this into your calculator into y equals, and it would give you this picture right here. Now this one is a little hard to see, especially because of this right here, but it's because your zeros are so close together. But they do actually cross through at the right numbers. So it looks something like this. But now I need to put in my y-intercept, which, remember, you look for your 0 for x, so it crosses at negative 6. So it's going to cross through here and go back up. When you're given a graph, instead of the zeros listed as numbers, the first thing you want to do is identify the zeros from the graph. And then you're going to use the distributive property to get the equation, just like we have for all the previous ones. So let's take a look at this graph. My first 0 is at negative 1. My second 0 is at 0. And then my third 0 is at positive 2. So what we're going to do now is we're going to set up our parentheses. And remember, we're going to do the opposite sign. So I'll have x plus 1. 0 is kind of funny. I'm going to put x minus 0, but we'll come back to that. And then x minus 2. All right, so for this middle one, 0 is unnecessary. We don't have to write it. So we could just write this one as x without parentheses, which means we'd probably write it in the front. So I'm going to write x plus 1, and then x minus 2. So this one, even though I have 3 zeros, I'm only going to have to do the box once, and then I'll be able to just distribute this x to the rest of my answers. So I'm going to take this part right here, and I'm going to make my 2 by 2 box. So I'll have x plus 1 over here, and then x minus 2. So I'm going to fill in the box. This would be x squared, negative 2x, 1x or just x, and then negative 2. I have some like terms here. So if I add these together, negative 2x plus x would give me negative 1x, or just negative x. So my final answer here would be x squared minus x minus 2. Now I need to take this and I need to multiply it by that x that was out in front. So this one right here, I'm just dropping it back down. And now I'm just going to distribute it like this. I don't have to make a box. I'm just distributing the x to all of the terms that I had. So I'm going to go up here. I would now have x cubed minus x squared minus 2x. And this would be my final answer. I don't have to do a sketch of the graph because that's how this thing started from the first place. So these are actually a little bit easier than the ones that we just finished. Next example, this is the same as the previous example. So the first thing I'm going to do is identify my zeros. So I have a 0 at negative 1, and then I have a 0 at positive 2. But this one is a double 0 because it doesn't cross through the x-axis, it just touches and then bounces back off. So I am going to need to have 3 sets of parentheses. One of them is going to be x plus 1, and then I'm going to have 2 identical factors at x minus 2 because I have a double 0, that positive 2, 0 has to count twice. So I have 2 factors. So this one, I don't have any conjugates, meaning I don't have anything that's the same number with opposite signs. So this one, we're going to have to do all the work. I'm going to start with these first 2. Remember that it doesn't matter what order you multiply. So I'm going to multiply these 2 binomials. That means I need a 2 by 2 box. So x plus 1, x minus 2. So I have x squared minus 2x plus 1x minus 2. So I need to combine my like terms, which is this right here. Negative 2x plus x gives you negative x. So what I end up with here is x squared minus x minus 2. Now I need to take this and multiply it by the x minus 2 that I ignored at the beginning. So now we're going to have to do the box, and this one's going to have to be a 2 by 3 box. So I'm going to have x minus 2 on the left, x squared minus x minus 2 on the top. So I'm going to go through and do everything on the top first. X cubed minus x squared minus 2x, and then negative 2x squared, positive 2x because I'm multiplying 2 negatives, and then positive 4 because again I'm multiplying 2 negatives. Now I have some like terms. I'd have negative 2x squared minus x squared for a total of negative 3x squared. And then I also have 2x plus negative 2x. That actually cancels itself out. So those end up not being part of our final answer. So here's what we've got. X cubed. The green part is my next term, which is negative 3x squared. The blue part canceled itself out, so all I have left is plus 4. So again, we don't have to sketch the graph. It might not be a bad idea to put this into your calculator into y equals, and then just check to make sure that your graph matches the graph that you started with. Because if it doesn't, that means that something with your equation is wrong, and if it does, you know that you got the right answer.